In this video, we're going to be modeling with vectors, and for this topic, we're going to be applying all of the skills we've learned so far in this series on vectors to modeling questions. So we're going to recap briefly what we've covered so far. So we firstly looked at unit vectors, about the fact that you can represent a vector with a column vector. So let's say you had some vector, and that was, 4, 3, something like that. You can also represent this as 4i plus 3j. So we looked at these unit vectors I and j. I was the unit vector along the x-axis, j was the unit vector along the y-axis. We looked at magnitude direction forms, so representing vectors in terms of their size and their direction. So if we had some vector like this, we looked at finding the angle either from the vertical axis or the horizontal axis. We looked at these angles and how you can represent a vector using either of those angles and its size or magnitude. We looked at position vectors, and this involved representing points on a 2D plane in terms of a position vector, so some vector from the origin to that point. We also looked at solving geometric problems, and we looked at a bit of a shortcut you could use. So let me write that down again. I'll write down the formula we were using. It won't make much sense without context, but we can give that in a second. So the formula looks like this. Lambda over lambda plus mu multiplied by OB take OA. Okay, so we looked at this formula, which I referred to as kind of a shortcut to geometric problems. It was referring to the situation where if you have two position vectors, OA and OB, and you have a point dividing the line segment between A and B, you can use that ratio that point divides that line into to find OP. So this point we can call P, and we can use that ratio to find OP. And we saw in that video that this situation comes up a lot, surprisingly. This very specific situation comes up a lot in these vector geometry questions, and this formula comes in really handy. So we're going to use these skills we've learned so far and apply them to some modeling questions. So let's have a look at the first example. This one says, find the speed of a particle moving with a velocity 3i plus 4j meters per second. Hopefully you can see straight away from this example that these modeling questions involve understanding a bit of the context of the question. So when it says find the speed, you need to understand that speed is the magnitude of the velocity vector. So velocity is speed with direction. In order to single out what the speed is, you just need to find the magnitude of this vector. And we've already covered how to find the magnitude of a vector when it's written with this ij notation. We just need to basically use essentially Pythagoras' theorem. So we can say the speed is equal to the square root of 3 squared plus 4 squared. Again, briefly, just to go through that, if we draw this vector, it's going to look something like this. Well, actually, let's do it a little bit more accurately. It's going to look something like this. And we're going across 3 units in the x direction and up 4 units in the y direction. And what we're finding with this magnitude is the hypotenuse of this right triangle with legs of 3 and 4. Okay, so, well, this should hopefully look pretty familiar. 3 squared plus 4 squared is 25. The square root of 25 is 5. So the speed there is 5 meters per second. So we're taking the skills we've learned so far and applying them in different contexts. All right, let's have a look at a couple of problem-solving questions. This question says, two forces F1 and F2 are given by the vectors F1, which equals 3i minus 4j newtons, and F2, which equals pi plus qj newtons. The resultant force R equals F1 plus F2, which acts in a direction which is parallel to the vector 2i minus j. Part A says, find the angle between R and the vector I. Okay, so we know what the vector I is. That's a unit vector in the x direction. So that's just a horizontal line, basically. We want to know the direction of R. Well, they tell us it's parallel to the vector 2i minus j. So what I'm going to do here is basically draw a right triangle with one leg of 2 and the other leg of 1, and that's going to represent the same angle as r from I. So this is 2i, this is j. So this is the angle we're looking for, again, because r is parallel to 2i minus j. That's this vector here, this one, 2i minus j, and negative j means we go down. So that angle would be the same as the angle between r and I. Okay, so now we need to find this angle. We can use the trigonometric ratios. I'll use tan because we have the opposite side and the adjacent side. Okay, so we're going to say tan of theta equals opposite over adjacent, 1 over 2. And then we need to take the inverse tangent. Let's get our calculators out. So let's take the inverse tan of 0.5, and I'm using degrees here. I'm not 100% sure. There's no indication in the question, although usually if it doesn't indicate radians or degrees, I would probably go with degrees. Not 100% sure on that. But I think, well, don't stress, in an exam it will never be ambiguous whether you use degrees or radians. So theta was 26.56. And let's round that off to 26.57, shall we? So let's say approximately 26.57. 26.57 degrees. Okay, that's part A. Part B says show that P plus 2Q equals 5. Alright, so this involves understanding what they mean when they say the resultant force equals F1 plus F2. Well, we know how to add vectors, so we can start off by adding F1 and F2 and getting an expression for that. So let's go ahead and do that. So F1 plus F2 equals 3i minus 4j plus pi plus qj, and then we can write this as 3 plus pi, and then plus, I'm going to write it as q take 4j. I just feel like that looks a bit neater. And we're labeling this r for the resultant force. And we know this vector is parallel to 2i minus j. Okay, so if we draw this right triangle again, now we don't know, like we can't say 3 plus p is equal to 2. We just know that the vectors are parallel. But what this tells us is that 3 plus p must be twice the magnitude of q minus 4, right? So the horizontal part of this vector is twice the size of the vertical part. That's what it's telling us when it says that it's parallel to 2i minus j. So if we want to represent these unknowns, p and q, in an equation and then solve, we can say that 3 plus p is equal to 2 times the magnitude of q take 4. Now you have to be careful with your signs here because 3 plus p is a positive vector and q minus 4 is a negative vector. In other words, it's going in the negative y direction. So when we're creating this equation, we need to represent the fact that one is negative, one is positive. Now it doesn't really matter where you put the negative. I'm going to put it here in front of the negative 2 q take 4. You could also, write it like this. Negative 3 plus p equals 2 minus q take 4. And my point there being that you just need to understand that this vector we say is a positive vector because it's going in the positive x direction, and q minus 4 is a negative vector. It's going in the negative y direction. So they're going to have opposite signs when we create that equation. Okay, now hopefully we can simplify this equation to p plus 2q equals 5. Let's go ahead and try. So expanding those brackets out, we get negative 2q plus 8, and then p plus 2q equals 8 minus 3, which is 5, and we're done, and we've got that equation as required. Okay. as required. Part C says, given that P equals 1, find the magnitude of R. Okay, so, well, we need to kind of work backwards here. We have an equation relating P to Q, so we can find Q as well, and then we're going to be able to plug those in here to the equation for R and find that magnitude. So let's firstly go ahead for part C and state that P equals 1, therefore Q is going to equal, let's write the whole thing out. 1 plus 2Q equals 5, therefore 2Q equals 4, therefore Q equals 2. Okay. Next, plugging those in, we get R equal to, I'm looking at this equation up here, we get R equal to 4I plus negative 2, so negative 2J, which makes sense, right? Because it was parallel to it was parallel to 2I minus J, so this is a multiple of that vector. So now we need to find the magnitude, which we are familiar with. We take the square root of the coefficients squared and added. So the square root of 4 squared plus 2 squared, that's the square root of 16 plus 4, the square root of 20, which is 2 root 5. And that's your final answer for C. Okay, so there was a bit of a exam style question. On to the last question for this video. Oh, I just remembered, I had a quick look at my notes of things to remember to mention, and I've forgotten them, but you need to remember when you're talking about direction in terms of vectors, we need to say this angle is below I. So for this answer, I would have actually lost a mark here if I just gave that angle. So we need to say 26.57 degrees below I, and for my answer for the magnitude of R, we need to say newtons because it's a force. So a couple of little errors there, and hopefully you don't make those same mistakes. So remember to indicate in which direction your angle is, or how your angle is related to the unit vectors, and remember to always label your forces. Okay, next question. It says a boat A has a position vector of 2I plus j kilometers and a buoy B has a position vector of 6I minus 4j kilometers relative to a fixed origin O. Part A says find the distance of the boat from the buoy. So it has a tip here, draw a sketch showing the initial position of the boat, the buoy, and the origin. That's exactly what I would suggest as well. So before I go any further with this question, I want to draw a quick sketch. So we have a fixed origin. Let's draw that down here somewhere. Let's call that O, and then we have a boat, which has a position vector of 2I plus j. So that's 2 units along the x-axis and then 1 unit up. So A is going to be somewhere here, and I'm going to represent that with coordinates. So A is at 2, 1. And then B has a position vector of 6I minus 4j, so that's 6 units along the x-axis and 4 down, so somewhere down here. Just say it's about here. And I'm again going to represent that with coordinates of 6, negative 4. Okay? And I'm going to join A and B and OB. Alright, so I need to find the distance of the boat from the buoy, and B was the buoy. So we need to find, well, we could find the vector AB and then find that magnitude. Basically, we're finding the distance, the difference between the coordinates. So we've gone 4 units along the x-axis, 2 to 6 is 4, and then from 1 to negative 4, that's 5 units down. So for A, all I'm really doing here, well, I'm finding the magnitude of AB, which is the square root of 4 squared plus 5 squared. Again, that's the difference between the coordinates. So that's the square root of 16 plus 25, square root of 41, which can't be simplified any further. And because we're talking about a distance, we should probably round it off to a decimal. So the square root of 41 is approximately 6.4, and that was in kilometers. Okay, so that was part A. Part B says find the bearing of the boat from the buoy. For this question, you need to think back to GCSE bearings, and remember, to find a bearing, you need to measure the angle from north clockwise to the direction that you're going in. So we're going to be looking for this angle from north around to the direction of the boat. In order to find that angle, we're going to look for this angle in here. We can find that angle using these distances. So we have this distance, this horizontal distance from A to B, that's 4, 2 to 6, and then we also have the length AB, which we just found. Okay, so for part B, to find that bearing, I'm going to be using this right triangle with, whoops, that's not a right triangle, with a leg of 4 and the hypotenuse of root 41. And I'm looking for this angle in here. So to find that angle, I can use sine because I have the opposite side in the hypotenuse. So sine of theta is going to equal 4 over square root 41. So let's get our calculators out. The inverse sine of 4 over the square root of 41 is what I'm looking for. That gives me 38.7 approximately. And then I need to subtract that from 360 to get the bearing. So 360, subtract that answer, I get approximately 321.3. Okay, so let's write down that approximation first, and then we can say the bearing of the boat from the buoy. The bearing of the boat from the buoy is approximately 321.3 degrees. Okay, so that's part B. Part C says the boat travels with constant velocity 8I minus 10J kilometers per hour. Verify that the boat is traveling directly towards the buoy. We have the magnitude of this vector AB. Let's go ahead and find that in terms of the IJ notation. And what we want to do is to show that it's a multiple of this velocity to show that it's traveling in the correct direction towards the buoy. So to answer C, we want AB as a vector, is basically what I'm saying. So we could use position vectors for this, as we were doing in a previous video. So AB, we said, would be OB take OA. Hopefully you remember that. If you don't, check out that video where we looked at position vectors. So OB was 6I minus 4J, and then we subtract 2I plus J. This is going to give us 4I minus 4 take 1 is minus 5J, and then we can see that is a multiple of 8I minus 10J, so that's equal to a half 8I minus 10J. And then we could finish with a statement like, as AB is a multiple of the velocity vector, we know that it's going towards the buoy. So something like that. So as AB is parallel to the velocity vector, the boat is traveling towards the buoy. Okay, so that was part C. Part D says find the speed of the boat. We did this in a previous example. The speed is the magnitude of the velocity, so we need to find the magnitude of that velocity vector. So speed is going to equal the square root of 8 squared plus 10 squared. That's the square root of 164. Because we're talking about speeds, generally you want a decimal answer. So the square root of 164 is approximately 12.8. 12.8, and that would be in kilometers per hour. Okay, then E. E says work out how long it will take the boat to reach the buoy. So we have that distance, AB, we have the speed. Now we need to remember our speed, time, distance formulas. So if you can remember any variation of that formula, such as speed equals distance divided by time, then you can rearrange to find time. So we're looking for time here. Time is going to be distance divided by speed. Okay, so let's say the time is distance divided by speed. We have the distance, which was the square root of 41. We have the speed. Let's write it as square root of 164. To make it as accurate as possible, let's plug that into the calculator. So the square root of 41 divided by the square root of 164 gives me 0.5. That would be in hours because the distance was in kilometers and the speed was in kilometers per hour. So let's convert that to minutes. It makes more sense to write 30 minutes than half an hour. So this is 30 minutes. Okay, so there you go. That was a few modeling questions. I hope you found that video useful. Please leave a like if you did. Subscribe if you want to see more. And I'll see you in the next one. Bye for now.